4 o'clock now we'll start, madam. Other participants also waiting, no?
Yes, sir. Yes, sir.
Yes, madam. You can start, madam. No problem. 54 attendees are there. Good, good. Good numbers are there, madam.
Good evening to one and all present here. I, Dr. B. Devi Vigneshwari, welcome you all for one-day webinar on Labview applications in electrical engineering by Mr. Shadi Mansi and Ralph Sadab. I now welcome Nisha ma'am to deliver the welcome speech.
Thanks, Devi ma'am. Good afternoon, one and all. On behalf of the President of Children's Education Society and Chairman of Oxford Education Institutions, Management, Directors, HOD, staffs and students of the Oxford College of Engineering, I, Nishasi Rani, Associate Professor, Triple Department, deem it a great pleasure and privilege in welcoming you all to the one-day webinar hosted by Triple Department. It's my great pleasure to welcome our distinguished speaker, Mr. Shadi Mansi, Professor, Jubail Industrial College, Saudi Arabia. Mr. Shadi Mansi has master degree in electrical power system and control. He worked in different industrial areas such as plastic, chemical, and mining. Currently, he is a lecturer at Jubail Industrial College, Saudi Arabia, and he teaches different fields such as controls, machines, drives, and electrical wiring. Moreover, he supervised different projects with industry such as solar system for industry, utilizing waste hydrogen for industry, investigating on converting waste hydrocarbon into fuel, and converting FGD gypsum from waste into an added value. Mr. Mansi is also interested in industrial automation field. He has many contributions in different seminars regarding the emerging technologies in this field. He supervised different JIC senior projects such as SCADA system, applying Labview in industrial communication, PLC versus TCS pros and cons. Mr. Mansi is a member in different national and international bodies. He is an IEEE and ISA member and KNX partner. Moreover, he is a member in Jordan Engineers Association and Saudi Council of Engineers. Once again, it's my pleasure to welcome Mr. Shadi Mansil on behalf of management, directors, principal, HOD, faculty of Triple Department, and students. I would also like to welcome Mr. Ralph Sapp, co-founder and vice president of Sapp RDS to today's event. Mr. Ralph Sapp has obtained MSc in Electrical and Telecommunication Engineering from Lebanese University in 2001. He is a well-rounded business professional with more than 20 years of experience in the industrial and automation consultancy and IT implementation in the MENA GCC region with National Instruments. Mr. Ralph began a second career as an entrepreneur, driving the company's efforts in developing the next generation of engineers, researchers, and scientists in their preparation for the Industry 4.0 and its impact on global job market. His expertise includes industrial IoT, digital transformation strategies, power, clean energy and smart cities, mechatronics, AI, AR, ML, and maintenance prognostics, DF, MI, MO, 5G, and RF research, ICT platform integration, and education and teaching consultancies. Once again, it's my pleasure to welcome Mr. Rav Saab on behalf of management, directors, principal, HOD, and faculty members and students of Triple Department. Now I request our HOD, Dr. V.S. Bharat, to brief us about today's webinar. Thank you, sir.
Thank you, ma'am. Thank you for the opportunity. Good afternoon to all. So first, I would like to thank the special speakers. Today's special speakers, two speakers are there. Really, I would like to thank them to accepted our invitation, and immediately they are with the busy schedule, they are sharing the knowledge during this pandemic with our academic fraternity. So really, it's a very great pleasure to welcome Professor Shadi Mansi sir. Is industrial experienced lecturer, means we can get a more and more knowledge from Professor Mansi. So really, we are very happy to join in this webinar. And one more professor, Rob Sapp, is having a 20 years of experience in the teaching. So that is in especially industry and automation. So such a huge experience and knowledge people through we are connecting this webinar, really very happy. So these speakers definitely during this pandemic, they are giving very valuable informations to our students, participants and lecturers, for everyone. So behalf of the Children's Education Society and chairman and directors, principal, and behalf of all the faculty members and students, welcome to this webinar session. So thank you very much, sir, for accepting our invitation and your valuable time you are spending with us. We are very great pleasure and very happy to hear about your webinar informations. Thank you, sir. Welcome to the Oxford Group of Institutions, sir. Thank you.
Thank you.
Thank you very much, sir.
Perfect. So first of all, now can I start now?
Yes, sir. Devi ma'am.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Can you start, sir?
Yes. Okay. So first of all, I would like to thank you all for inviting me and Mr. Ralph for this very important seminar. Personally, I believe it is very important to have this kind of exchange of information and knowledge between universities and industry as well, to expose what we have reached from, like teaching point of view and from the industrial point of view as well. It is very important in this, maybe the pandemic, it has so many downsides, but actually it has one good side, that people start using this technology in order to explore that, transfer the knowledge is easier than what we are thinking. So our seminar today is basically about our experience here in Jubail Industrial College, basically in using Labview in engineering application, especially in electrical engineering application. And we had a good experience. We are, start adopting the National Instrument and Labview equipment since 2008, mainly in electrical engineering department, mechanical engineering department. And we found that it is very, very useful tool for for students in order to understand many things that they will face later on when they go to the field. So we are using it in control engineering, we are using it in network analysis, we are using it in heavily we are using it in senior projects, as well as in mechanical engineering department. They are using it in so many other courses that it has to have some kind of analysis for real processes. So we are getting data from real processes as it is, without simulation. I know from academic point of view, people would like to go with the simulation like MATLAB and other powerful tools. But when it comes to reality, we have to have real data, and we have to, get this data into computer in order to make real analysis on real data, real process data, not, having a noise and click some kind of generating something in order to do some analysis. No, we are talking about real data, which is basically what the student or the engineers, inshallah, when they go to the industry, they are going to face this problem. So we found that it is very useful, and I would like to share some of our experience and our finding here in national in NI, and we will have some kind of application as well through the seminar. Now, in this seminar also, Mr. Ralph Sapp from Sapp Institute and company, he's going to join the seminar as well, and he's going to highlight the application, the real application of National Instrument and Labview and other products for National Instrument, where students and engineers, can utilize these tools in order to implement their projects. It's going to make their life much, much easier. So as a start, let me start with the presentation. So I'm going to share the whole screen with you, and then I will go to my presentation. So as we said, basically this seminar is going to be about Labview application electrical engineering. I hope that, or I think that most of the students, at least they've been exposed to Labview in somewhere in their life, or at least when they were searching in the internet, or maybe some of them they utilize, like Labview in their lab. Definitely it has to be a must. Now Labview is as important. I know, like I came from, like when I finished my master degree, all what we have done, it was MATLAB. This was in 2001, 2002. But then here in the region, we start, like adapting also Lua and Labview in order to do the research and the analysis as well. And it was very, very powerful tool, as I just explained. So basically, as we said, now in this seminar, I'm going to highlight the real life application of Labview and National Instrument, and the main feature of this graphical based programming. I'm going to explain what is the graphical based programming. We have so many languages now they are used. The classical one, the conventional one, is the what we call it, the textual based, and then for like PLC we have ladder diagram, functional block, and sequential, and so many languages you can find it. But like the one which start also to grasp the attention as well is the graphical based programming. People who are like familiar with Labview, with MATLAB, it is very much similar that like using Simulink. Like in Simulink we have blocks and so on, and you can connect the blocks together. And I'm going to explain it just in a while. So first of all, I'm going to highlight this part. Then the second part of the session is going to discuss like how to be more comfortable with the data acquisition. What is data acquisition? How Labview and National Instrument are using these data acquisitions in order to acquire the data. And then I'm going to end up my seminar with some useful links that maybe the students and the interested people in the Labview can go to these links and forum in order to grasp more information. Now, the seminar is going, as I said, is going to be two parts. I'm going to go with the first part, which is the introduction about Labview and its some application. Then Mr. Ralph is going to join me in order to highlight again on the application with real data. Ralph, are you here, Ralph? Okay, so he will join in a while. No problem.
Yes, Shadi, I am here.
Perfect, Ralph. So the session outline, as we said, is going to start. My session, or my part of the session, is going to be introduction to Labview, why, when, and these W questions about Labview. Then I will go to the programming. It's going to be very simple example, very simple. I'm not going to go in details, but to explain what is the graphical based programming. Then I will go to that data acquisition with a very simple example. I have with me now a data acquisition. I'm going to explain just a little bit to explain what is the data acquisition and why it is important. And then I will go to some supplementary material. Of course, the questions, then Ralph will come, and then we will go to the question part. So let's start with Labview. Now, Labview is a system engineering software designed for engineers to develop application, measurement, and control. Basically, this is one of the main application of Labview and National Instrument components like data acquisition and so on, where we are going to develop. Yes.
ಹರಿ ಅವ್ರ ಹತ್ರ ಯಾರೋ ಇನ್ನೊಬ್ರು ಇದ್ರು, ಹರಿನ ಯಾರೋ ಇದ್ರು ಅಡ್ಮಿನ್, ಅವ್ರ ಹತ್ರ ಮಾಡಿಸ್ಕೊಂಡ್ರೆ ನಾನು ಯಾರನ್ನೂ ಮಾಡಿಲ್ಲಪ್ಪ.
Sorry. I think the mic is on. Some of the attendees, his mic is on. Okay. So first of all,
just a minute, sir. Devi madam, please kindly mute everyone, madam, except the speakers. Everyone, please kindly mute them, madam.
Yes, sir. I have muted. All attendees
sorry,
are muted.
Mansi, sir, it is unmuted to some people. You please continue, sir.
Okay, perfect. So as we said, we have using Labview and, for example, Labview and XG, we can develop an application. We can develop a program. This program is going to measure, like some data, real data from a processor, from motor, noise, oscillation, or whatever. And then we can make some analysis in order to design an algorithm, in order to control something. So basically, this is the whole idea, if we can look at in holistic approach. Now, Labview, basically, it was developed by National Instrument. National Instrument is an multinational, actually, company, and they have so many products. Labview is only one of their software, but they have software products and hardware products. I believe Mr. Ralph is going to introduce this part better than me. But you know, like, they are not only for software for data acquisition. They have so many programs. One of these programs is Labview, and they have other products, you know, like the hardware which is compatible with Labview. I'm going to just, you know, like, highlight it in a little bit. And then they are working with something called virtual instrument. Virtual instrumentation, we are talking, like, for example, if you have a voltmeter, if you have, you know, like, oscilloscope or whatever, these are real instruments. Now, in Labview, all of these instruments can be done, you know, like, in the programming. All what you have to do is to drag and drop the block, and voila, you will have your instrument there, which is virtual instrument, but the data you will get it through the data acquisition. And this is why they have this unique extension for their file. Their files for Labview, they call it, their extension is VI, which stands for virtual instrument. So if you start any program, it ends with .vi, you know, like in document.docx, for example, Excel sheet, XLX, and so on. For Labview, it ends with .vi, which stands for virtual instrument. Labview FACS started in 1986. It is a graphical-based program. I'm going to explain it in a while. And it works with data flow properties. I like this part, you know, like the data flow properties. I start, you know, like, from the left of the screen, and then I will start putting all of these blocks and toolkits together in order to end up with, you know, like, the results. So if I want to, you know, like, review my program, I can. This is the beauty of graphical programming. I can start and I can follow up what happened to my data and how the system is going to manipulate it in order to find the results, and it will be easier for debugging. You know, like, the good thing in Labview that it operates under Windows, Mac, Linux, and Unix as well. Right. Why to use Labview? Well, Labview with, you know, the Labview, the software, it works basically with any vendor. Any vendor who's, you know, like, has its international standard of communication protocol, whatever the protocol is, then if you have the right data acquisition, then Labview can get to your hardware. It can get it, and you can get the data, and then you can manipulate it, and you can put it back to that instrument. For example, I did a lot of projects with my students using, for example, this DDM, for example, or oscilloscope, which can be connected through USB. All what you have to do is connect it to the computer, and you have all the data, you know, like, of the oscilloscope. You can do whatever you want to do with the oscilloscope from the Labview. Just, you know, like, drag and drop the right toolkits, and then you can manipulate the oscilloscope. Whatever you are doing in your hand, you can do it through the Labview, and you can get the data. And the other thing is, once you get the data, you can analyze these data. For example, if you are working with the signal and systems, you are working with network analysis, circuit 1 or 2, electronics, whatever. Once you get the data, you need to, for example, you want to find fast Fourier transform for that signal. You can do it here in Labview, and based on that, you can make decision. If you have a frequency, it comes in the oscilloscope, you can get the data, for example, because you can use the oscilloscope as your data acquisition in this case. And then you can, for example, find the frequency, because you get the real data in the process in your computer, so you can do whatever you want to do, you know, like manipulating or analyze the data in order to find it. By the way, it is easy in Labview to do that. You have to find the right toolkit, which is a subroutine. It is already done for you in order to get this data and to make the analysis for yourself. So for the students and for the engineers, I believe it is excellent. In my projects, for example, with the students, or, you know, like, some analysis I did for the industry, I focus on my projects rather than spending time on getting the data, making signal conditioning, then having a routine to find the right frequency or FFT or whatever you want to do with that. It is already written. All what you need to do is, I will show you later on, and Mr. Raf, I believe, is going to give some examples. All what you need to do is to put the right toolkit, put the data, enter the data to this toolkit, and you will get your results. Then you have to focus on what you want to do with these results. Where is your project? So you will spend, you know, like 90% of your time doing your project rather than wasting 60%, I believe. I remember, you know, like 15, 20 years ago when I was, you know, like in school, I was spending 60% of my time in order to, you know, like signal conditioning of the data. The operation amplifier is not working. The computer visa card, it has a problem. There is a problem in the subroutine to find some kind of analysis of the data that I needed to make my project. Here using Labview, 95% of your time is going to be focused on your project because Labview is going to make and done all of these analysis for you in 5-10 minutes maximum, and then just go directly to your project. Now, this is an, you know, like an example just to explain to you what do we mean by graphical programming. For example, here, just like a block diagram, I have, let's say, you know, like I start here initiating the data, then I will make some analysis on these data. One of these data, let's assume that this block is the data acquisition, which is in reality is connected to a process. So I get the data acquisition is getting the data from the process, and then I will manipulate the data later on, okay? So this part will take from you exactly 3 minutes to configure the data acquisition, okay? 5 minutes, 3 to 5 minutes maximum to make the right configuration in order to acquire the real data. Now, most of the time is going to be in your project. I'm going to multiply, I'm going to find, you know, like finding the maximum frequency, minimum frequency, I'm going to find the RMS value of the signal, whatever you want to do, and I'm going to make so many manipulation in order to get an output. And this output, for example, is going to be a control signal. It go back to the data acquisition in analog output or digital output to control your process, okay? So basically, it is very easy. And as you can see, you can go, you know, like with your program, it's very easy to understand and to follow up, debug your program, okay? And the other thing is, as you can see, there are so many built-in libraries. For example, filters, FFT, whatever, just name it. And you can put it here and get the data in order to do the analysis. Now, the good thing also with Labview, which is I found it very, very unique actually. For example, this is a simple one. Maybe it's not clear later on, we will see it. I get some data, I make some analysis. However, I need, because I'm familiar with MATLAB, for example, or I'm familiar with C language, or I'm familiar more with Python, but I need to make some analysis using my way, not Labview or whatever, or I'm you know, like my algorithm, it comes here and it needs my interruption and to put my data. So you can open a window here in order to put your textual-based programming, or what you need to do is to define the input here. So the textual-based programming, where you want to have your input, is going to open a window, write your program, and then you have an output, then you can continue. So basically this textual-based programming, as you can see it here, it can be, you know, like this block. So whatever the data is, you put it here, then you write your program, as I said, in C, MATLAB, Python, whatever, and the output is going to be a variable, which is going to be an output. Then it continues with other toolkits and libraries which already existed in Labview. This is the first part of Labview. The second part of Labview is the front panel. As you can see, this is the front panel where you can find the output. So the output is going to be, it looks like something like SCADA windows or these, you know, like window, DCS windows, when the operator and engineers are looking at their, you know, like a plant, and they see what is going on. So you can find it here in the front panel. So the front panel, it is like industrial based. So even the students, when he goes to the industry, he will be familiar with these windows and these toolkits. Now, let's go with some applications. I selected some applications and, you know, like real applications of using Labview. The first one, I found it here in the internet. To be honest with you, I went to the internet to see how other people are using Labview. So, for example, this is a good example. If we assume that we have this controller for, you know, like some games or so on, and you are having, you know, like producing thousands of these products per day, and you want to have some kind of control quality. So it will be impossible to have 100, 200 people who's going to check it one by one. So basically you will have a machine, and this machine is going to make the test very fast to check each product that it passes the, you know, the quality assurance or not. So these machines, like the hardware, it's going to be, like you have to design it. But when it comes to the software and acquiring data to make sure that the product is doing its job, it can be done through, like Labview and the data acquisitions or whatever equipment you need to do. For example, I can check the power supply, it works fine, the control tester, the vibration tester for the controller, wireless tester, all of these. If it passes, like there will be signal, then like we will get the output from the control. If the controller passes, it will take seconds, and then you bring the other one, All of the process can be automated, okay? And then you can have a full, control of quality control of your product. The second application basically is the industrial one. It works Labview for the industry. Actually, National Instrument, as I know, is a third party for many major companies like Yokogawa, Delta, Emerson, and so many other, like big, gigantic industrial companies in the world. They are the third party. They are providing them with equipment, or you can use it, the whole, system. If I want to make a control system for a power plant, I can, like utilize most of the National Instrument, like equipment as a data acquisition, compact trio, or any other controller, because as I mentioned in the beginning, in National Instrument, they have two parts. They have the language, the software, sorry. One of them is Labview. They have other software, and they have even the hardware, like data acquisitions with so many types of data acquisitions, or they have also the controller. It starts with a small controller. We can go to big controller like compact trio or SCXI or so many other types of controller. So if I want to have a plant and I want to make a control system for it, then I can use even the National Instrument. National Instrument and Labview is not basically, like only for the research and for universities. Actually, it is used. It comes from the heart of the industry. Then it goes also to serve the academic. This is what I discovered. It is different than Labview. Labview, actually, if you go to the industry, you will not find, it's not Labview, sorry, MATLAB. If you go to the industry, you will not find MATLAB there. When I finished my master, I went there. I am familiar with MATLAB. I am actually professional in MATLAB. But I discovered no one is using MATLAB in the industry. However, when you go to the Labview, even if that industry doesn't use Labview, but you gain a lot of information and knowledge and skills, which is going to fit directly with the industrial need with the Labview, because now you are dealing with real signal, with real data acquisitions, or even controller. So just in short, if I want to control a power plant, then I can, like I have National Instrument, they don't generate, like the thermocouple or RTD. But whatever the thermocouple or transmitter, temperature transmitter you bring, it can be connected to their controller. So for temperature, pressure, vibration, all of these sensors or transmitter can be connected to the Labview equipment in order to make your analysis. So for researcher, for example, they like using Labview because they can work with the real, with real equipment, real process data in order to, like make the analysis. So same thing, it can be done for the industry. Voltage, current, whatever, just name it. And you will find, for example, in compact trio, whatever you have, you will find the right card in order to connect it directly to the compact trio and to start working with it. Now, like the third part is for students and research in university. This is the part I like. This is the part I spent the past 10 years working with it, where, like, I find it's very easy for a student to go with it and more professional. When I'm working, for example, with what is it, Arduino or Raspberry, they are fantastic, but it works for some kind of project. They have so many limitations. Okay, for example, you have analog input in compact trio. In Arduino, you have analog input, but you cannot make analysis on this one. So it is like 0 to 5 volt. If the volt reach a point, then you can do whatever you want to do. If you want to write a program to make analysis, then you will consume the Arduino data. And it is very, very limited with the sampling time, limited with so many things. But when you go to level, for example, you want to control a robotics and you want to have, like every microsecond counts, then of course, you have to go with more professional and more, like accurate software and hardware. And here it comes, like National Instrument equipment. For example, when you are working with a drive system, some of the project I did in a drive system, for a drive system, like millisecond is huge. I have to go in something like less than 1 millisecond in a drive system, for example, where you have very, very delicate process. Then of course I can go with National Instrument, and you will get, like in microsecond, even in and less. So it comes in these applications. When the student work in these applications, he will be familiar with analysis in one hand, and on the other hand, he will be familiar even, like how to connect your computer or your controller with the process. So he will understand what does voltage mean, what current transmitter mean, what are, like the difference between reference signal or floating voltage, or like single-ended differential inputs. All of these, like the student, he will put himself in reality, and he will start making the connection, and he will start understand the difference between these. So when he goes to industry, he will face the same, like these questions. I will just, like go fast because I want to give the time for my colleague Ralph to explain his part. So Labview programming, as I said, now I will give you a small example, just one example for Labview. Here now there are like two releases for Labview. We have the Labview, the conventional one, which was started in the 1990s. And now Labview, they are working with something called Labview and XG. From what I understand, like as engineer, maybe Ralph can correct me. Labview and XG is, like the more advanced version of Labview. I think it will take over in the next 5-6 years, if I'm not mistaken. This is what I understand. When I work with Labview and XG, it looks, like 90% like Labview, but it is different environment, and it has, like so many features compared to Labview. So I believe it's just a matter of time, and then it will go to the next release of Labview, which is Labview and XG. Okay. Now I will give you a very simple example. Here, for example, if I'm getting a data of, for example, the Celsius temperature, and I want to convert it to Fahrenheit. If I want to work with a textual-based programming, where most of the students and like instructors are familiar with, so this is a C language program. It is straightforward. I believe everyone is familiar with this routine. But if you want to make it in Labview as a graphical-based programming, you can see I have to put the data here, okay, as a Celsius. Then I have to multiply it with 1.83, then add like 32, and then you will get it. As you can see, this is the beauty of the graphical programming. You start from here, and you know what you are doing, and then you can get it. This part, it can be done as like a sub VI, and once you want to convert from Celsius to Fahrenheit, all what you need to do is to you make it like a box. We call it sub VI. You can call this sub VI anywhere, and then it's going to be like one of these boxes later on in your program. Okay, so as a start, let me start with this one. I'm going to do only this one, just to be familiar with the windows of Labview. So I'm going to escape this one. I will go to my Labview. Okay, and here, for example, I can create a project. A project in Labview, it means it's going to be, you have a lot of Labview programs working together in order to do some function. Or I can go only with a blank VI. VI, as I started, it stands for virtual instrument, where the student, the file itself is called virtual instrument. Let me click on it, and I'm going to click finish. So as you can see, we'll have two windows. Where's the second window? Control E. Okay, here it is. So we have two windows. This one is called the block diagram, and here is going. We call it the front panel. The front panel, let me maximize it. It looks like what like we have it in a SCADA system, or we have it in the DCS windows. Like the gray background, and you can put your data here or whatever. So I'm going to start with the numerical control. For example, this is a numerical control where I have to put my Celsius, and there at the end I will get the numerical indicator, which is in Fahrenheit, and this one is going to be in Celsius. Okay, sorry, let me just Celsius. Okay, The program itself, the program is going to be in the block window, the other window. And as you can see, whatever you have done here, it will be, it has its reaction in the block diagram. And now I'm going to do the conversion. The conversion, as we said, we have to, I think, multiply. Let me check. I forget it. Just a minute. Okay, so multiplication and addition. Okay, so first of all, I'll go to the math. As you can see, it is very easy. Multiplication, and then I go to numeric. There will be addition here, and here I have to put a constant, create a constant, and here I will create a constant. Okay, now the Celsius, for example, which I put it here, or it could be a data acquisition, you know, like I can get this signal from a data acquisition. Okay, it's going to be a voltage, then I will manipulate the voltage, then it represents the Celsius, then I can, you know, like making all of these things. So whatever the source of the Celsius you got it, it will be connected here, and this one will be connected here, and this one will be connected here, and here's, you know, like as simple as this. This is what I've done in order to convert the Celsius into Fahrenheit. I need to change these data. Let me go here, 1.8 and 32. Okay, 1.8. So this one will be 1.8, and here will be 32. 32. Okay, it's as simple as this. If I run it, for example, Celsius, 0 Celsius is 32, right? So if I change the Celsius into, for example, 100, what is the 100 Celsius in Fahrenheit? It will be 212. And so on. So basically, this is how easy it is to make a programming in Labview. So if I want to go through Labview, just very quickly, you can see here, you know, like the version I have it here, it is academic license. So I have most of the, you know, like the toolkit I can find in Labview. So for example, basically, as you know, like in our college, we go usually with the Express, or we go to the instrument input output, measurement input output, or we go to instrument input output, or sometimes we go with the Express for the input, for example, and the input is going to be data acquisition. I can put the data acquisition here, okay? And you will see how easy it is. For example, now it is open. I want to acquire data, which is going to be either I can go with analog input, counter, digital, TDS. I will go with the analog input. Is it voltage, temperature? You know, like all the types I have, I will go with the voltage, because let's assume that it is connected to a data acquisition, okay? And it's going to measure only the voltage. So we have a thermocouple or whatever, and then I have a signal, and then I want to connect the signal to the data acquisition. I will start with analogs, you know, like analog input 0. If you go through it, as you can see, we have in this data acquisition I have, its number is USB 6215, and it has 15 analog input. It can work with 15 analog input. So I can say finish. Here I can, you know, like make test on the on my data acquisition. Here I can choose the type of the, you know, like terminal configuration. Is it differential? Is it reference single-ended? Is it non-reference single-ended? You can choose whatever you want to choose. I can choose, you know, like the rate of the acquiring data. Here we are talking about 1 kilohertz, okay? Sample rate is 1 sample per 1 kilo. And, you know, like for this data acquisition, which is isolated data acquisition, it can work from 10 to -10. No, wait. This one, USB 6215, I think I can go up to 60 volt, if I'm not mistaken. Anyway, so I can even decide what is the maximum and minimum, you know, like voltage. For example, let's say like 0 volt. And then if I press OK, the data acquisition as configured is ready. All what you need to do is to connect your transmitter in voltage, which generate a voltage, to analog input 0, and this data acquisition, the data, for example, I can delete this one, okay, Control B, and the data will go here, okay? So, you know, the real data, which is acquired, for example, in Celsius, now I can change it into Fahrenheit, and I can get my value here. I can make a lot of things, for example, comparison. For example, if it is greater than, let's say, if it is greater, if the signal is greater, let me control Z, just a minute. Okay. Now let's assume I will go here because it will be easier. Now I did not connect my data acquisition to any signal, but let's say if I have a comparator greater, so if the signal, which is in Fahrenheit, is greater than, let's say, 200, create a constant 200, then I will get some kind of an alarm, create not a constant, create an indicator. Okay, so if I run it, as you can see here, I run it because the Fahrenheit is 212, then I got, you know, like what we call it, digital signal. This digital signal, I can put it in another data acquisition, for example, to start an alarm or to start a cooling system or to do whatever. So as you can see, it will be easier for you to use the Labview because you will focus on a project rather than focusing on like acquiring data and, you know, like generating signal, making sure that things are connected. This part is done already by Labview. Okay, I think I took a lot of time. Ralph, are you here?
Yes, Mr. Shadi.
Should you take over now?
Whenever you wish.
Okay, because I want to give Ralph the time.
I'm actually amazed and speechless with your nice presentation.
Thank you, Ralph. Thank you very much. I just want to finish these 2 slides and then I will give you the mic.
Excellent, excellent.
Perfect. So the data acquisition, for example, this data acquisition, you know, like how the data acquisition works. It has 3 steps. First step is the sensor, which is connected to the process. Then the second part is the data acquisition, then the computer, where you have the Labview and you want to make your analysis. Okay, basically this is the data acquisition, how it works. So as we said that we have the sensor, then we have the data acquisition, and then we have the computer. Now this is the original one. Data acquisition, it could be a data acquisition. This is a national instrument data acquisition. By the way, even if you have different data acquisitions from different vendor and you have Labview, it can work with these data acquisition. It has no problem. I connected with, if I'm not mistaken, from Taiwanese one and one from Denmark, different, you know, like vendor from data acquisitions. But, you know, like I don't want to use with Python or C. You know, like I want to focus on my projects with my students. So I use Labview and it was working perfectly fine. I didn't find any problem. The other thing, as the example I made it in the beginning, sensor, for example, which is the probe of oscilloscope, you can connect your computer to oscilloscope with Labview, and you can get the data which is in the oscilloscope in your Labview, and you can make the analysis. So you can utilize even your lab equipment or other devices or other vendor equipment to get the data, and then you can start with you know, like the analysis and generating the control signal and so on. Okay. I think the sampling system, most of you, since you are engineer, you have to be familiar with this one. I think this presentation, I can send it to the organizer, whereas this slide is very important, where you can find, you know, like some resources for Labview. You know, like ni.com is amazingly important for any student to go, especially who are working with control and electrical engineering. If you go to ni.com, you will find, you know, thousands and thousands of documents. Even, you know, it works like a tutorial. For example, it was, for me personally, it was useful for, you know, like Modbus, to understand the Modbus, the OPC, to understand the RSE, non-RSE, and differential. And I got a lot of data, and I made some manual to my students from the National Instrument. So it was useful for me. Labview community, it is amazing, where people, they talk to each other, and you can get data from them, and you understand, you know, the problem they face, and you know, like it will save your time while you are working with other, you know, like projects. Learning modules, there are a lot of learning modules. If you have, for example, academic classes, and this is what we are doing in my college, for example, and you can go to very interactive, amazing learning modules for National Instrument to understand even more, you know, like with the data acquisition and controller. The good thing with National Instrument and Labview, it has different exams and certification, and this certification is internationally recognized. For example, CLD, CLA and CLED. You can go and search for these, and you will understand that if you have, for example, CLD, then you have this knowledge of programming. Maybe you are programming with Labview, but also with this engineering level as well. So this is why it is internationally recognized. The Labview certificates are internationally recognized because in addition to Labview programming languages, it means that you know this knowledge also of engineering as well. Labview forum as well, and you can go to with Google and you know, like YouTube. A lot of universities, they are publishing a lot of, you know, like tutorial in Labview, so you can find these data. You know, like I think you can find it there. So this is all what I have. Believe me, it is impossible to finish your presentation talking about Labview in 1 hour or 2 hours. You need, you know, like I took a lecture for Core 1 and Core 2. It took 2 weeks, 1 week actually, 1 week, 8 hours a day, and it was not enough for me. But you know, like I hope that at least I presented to you the importance of Labview and National Instrument equipment for you as, you know, like student in engineering, how important it is, and I hope that, you know, like it was very useful for you. Ralph, the mic with you now. I'm sorry if I took some of your time, but the mic with you now.
Thank you, Shadi Mansi sir. It's really very informative. So once again, I will welcome Rock Shop sir. Actually, while initially during that welcome speech, sir is not in the meeting. So now just he joined us. So welcome you, sir, for this Labview for Electrical Engineers webinar series. So really be thankful to you. You are also accepted our invitation and joining. So Rolf sir, welcome you.
Thank you, sir. Thank you for the organizer, for the committee, for the attendees, for your time and for your interest. And thank you again, Mr. Shadi, for this excellent presentation. I am speechless. Let me share my screen. Is my screen visible right now?
Yes, sir.
Yes,
It is visible.
sir.
You can see.
Okay, thank you so much. So why Sapp RDS? So Sapp RDS stands for Sapp Research and Development Systems. We are an eye distributor in the Gulf region in Saudi Arabia, Bahrain, and Lebanon. We founded this company 2 years ago. However, as the organizer, they already stated in my biography that I've worked with National Instruments for over 16 years. Now, due to the latest challenges in the market, we understood that we need to think and to like kind of solve the local challenges in a different way. That's why we created Sapp RDS to bring up a value added into the National Instruments technology and products. So that's why, as our mission stated, we want to bring a sustainable productivity gain with a human touch and enlight our vision with sustainable success, and to highlight as well our ethics, value with utmost integrity to service our customer in a very good way. So the challenge is that after the nice presentation of Shadi, and he brought up the high importance of using National Instruments tools and software and hardware based on the virtual instrumentation philosophy, we came up with a certain consortium of National Instruments ecosystem. So we want to complete the picture in order to service today's needs and today's challenges, where most of them, they are related to the equipment. So I don't know, are you able to follow? I guess there was some small interruption. Hello?
Now we can
Yes, sir.
hear you.
Now it is fine.
Yeah, perfect. So National Instruments as the main core business, around it we have built several NI partners like Elcom, who is the first one here on your left, which are specialties in the power industry. Then we have our other partner, Quanzer, based in the research in academic and mechatronics, drones, UAVs. Also, we have a partner called Digilant, which is another company that is owned by National Instruments, actually, and they are experts in electronics. Also, Bitlessman, who are expert in SCADA systems and smart airports and smart production line programming. In addition, we have some businesses consultancy company like Allied Reliability based in the States for machine condition monitoring, assets monitoring, also one of main pillar, which is PTC related to the augmented reality, the artificial intelligence, CAD design, and PLM, like product life cycle management. Our main partner as well in this consortium is Novator, who are specialized in the aerospace and defense and signal intelligence applications. And last but not least, we have CB Technology, our main partner in the connected workers. I'm going to be highlighting this point a lot during the presentation, which is the one which is top priority in the industry demand today, the connected workers philosophy, by leveraging all the previous expertise from Novator, PTC, Allied Reliability, Elcom, Concert, Digilant, and Bitless around National Instruments technology. So the scope of management, we're gonna start by Sapp's RDS consulting. Sapp's RDS helping you in building up your intellectual property, all of them around a very open platform. You wanna build your library. We wanna also enable you to do services and value-added consultancy business, also to provide end customer solutions in addition to the system integration. Some of our top customers in the Kingdom of Saudi Arabia, like we have Tasnia, we have Kaust, Kaxt, Aramco in oil and gas business. We have also lots of research and academic institute that they are around the petrochemical industry and non-petrochemical industry like elastomer, aerospace, also as it's mentioned here, very highly highlighted, the Royal Commissioning for Jewel and Yambo, where we have our friend and our colleague Mr. Shadi, and many others. So nowadays trends which are driving the industry disruption and which is our guide. You see, those are some statements from top consultant company around the world, like World Economic Forum, the worker shortage, 10 million jobs with manufacturing organization cannot be filled today due a growing skill gaps or skills gap. Then from JP Morgan, we have the risk and cost pressure, a global manufacturing PMI, the Purchasing Manager Index, which is at its lowest level since 2016 due to the deterioration in global export order and business conditions. In addition, one big statement from Stanford and Poor's, where the digital disruption at the current churn rate, it's about half of today's S&P 500 firms will be replaced over the next years. So some of the top companies that you see today, after five to 10 years, they may no longer be existing and they might go bankrupted. We remember the Kodak momentum. Now let's go back to some good points where we can see where National Instruments technology is present. And it seems that it's used in over 30,000 multinational companies, that they are occupying more than 95% of the industry. And you can see that's a very high variety from telecommunication to oil and gas to defense to many other fields like in automation, in automotive industry, electric car, energy, electric energy, green energy, and military research and automation as well. So let's focus in this remaining part of the time that is allocated for me on the academic teaching and research. Nowadays, trends in the academic industry is there is the high grow enrollment and reduce attrition. And in order to leverage National Instruments technology that they are built around the multidisciplinary systems, we are encouraging the project-based learning approach, which it turned out that to be this is the most feasible way of transferring the technology from the teachers and from the books into the students. And we have used not only teacher to student approach, but also we have leveraged at National Instruments ecosystem the student to student philosophy. Through the very well said slide number 24 by my colleague Mr. Shadi, slide number 24 about the certification, how we can leverage the certified student and the certified professors, where we can launch Labview and National Instruments Academy. We have created a very huge network of Labview academies around the world where students can exchange know-how, exchange expertise. And also we have enhanced the philosophy of the Labview student ambassador through several clubs where we enhance the student-to-student approach and where we can have some students, certified students teaching their colleagues and creating after-hour sessions. After all of this momentum and energy, we can build together something called the Labview Center of Excellence, where these Center of Excellence works and be constituting a very important place of partnership between university, the researcher, and National Instruments to be as a feedback to us to work together to create a new product. Something that is very important to observe and where we have a very huge similarity between the Indian population and the Arabic population, which is a very young generation. As you see that the population grow rapidly. And this is the small example how we have now in the Arabic population over 90 million pool of students moving into higher education. So this is a challenge for us. Challenging in high unemployment, which is something very common between the Arabic countries and India as well. The private higher cost education is growing as well in the region, which is constituting at least 20% of the total business. Engineering seen as one of the most exciting fulfillment profession by youth in the region, and the most important is the investment by the knowledge-based economy, how we can localize the technology locally in order to service the market need. Today challenges, we have extreme lockdown. We have lots of difficulties to move from one city to another city, to travel from one country to one country. That's why we come back to the first slide. Connected workers, networking, knowledge-based economy, how the local startup companies and incubators will be able to service the local industry in the regions and overcome the challenges. So there is a huge presentation that it might take several hours. I'm gonna stop it here, and if there is any question at the end, and I will be more than happy to address. As a small briefing before I go back to the hardware session and the demonstration on Labview, I would like to highlight to you that we have a full curriculum that we can service in the electrical engineering to cover all years of educations of engineers from the first till graduation, even up till the postdoc level, mechanical engineering, civil engineering, K-12 program as well, because we believe that preparing the future scientists start from the early high school program. So we want to give the small students like secondary and elementary students the good approach and the good STEM education in order to prepare them for the future challenges. And remember what? We should be advancing the industry, because what we are going to teach them now today, it has to be in advance of what's going to come up in the industry after 5 to 10 years. so they can find a good job and have a good employment rate. And that's why we believe that the education must be in advance to the industry rather than the opposite, where the industry will look after us in order to search for the new talented graduated student to take them in order to increase the employability and increase the industry level and quality. Okay. This is a small picture or outlook of the region or outlook of the industry, where over 50 billion connected devices, they were established by 2020. And we have witnessed over 50% of increase of connected workers. Everything is turning into becoming a smart machine. Like today, you have the smart TV, you have the smartphone, you have the smart washing machine, we have the smart fridge, the smart air condition. We have everything connected workers, the smart cars, and everything around us is smart. Now, I'm gonna go now into visualizing to you some of the Labview features that to complement what my colleague Mr. Shadi already elaborated. That's why once you have Labview installed, and there's a quick answer to the Labview NXG question that it was brought out earlier. So the NXG is the Labview next generation, where Mr. Shadi stated earlier, it might be the Labview of the future. And it's similar to the industry of the future, where we are enriching it with lots of toolkit to make it very affordable and easy for the biomedical engineer, for the professors, and for industrial people who are not engineers, like for example for doctors at the hospitals. So these guys, even they must have at least the technology available for them in order to be able to service their needs. Okay, so let's see now some of the software that we can have immediately upon installing Labview. It's Max. So Measurement and Automation Explorer, you can simply launch it. And this is here where you can start using your data acquisition and start applying some algorithm of simulation related to virtual instrumentation even before having the hardware acquired. Like let's say you have ordered the hardware, but the hardware is still at customs and it didn't arrive to your facility. You can now create the simulation device to start your code and start your program from day one. One of the nice data acquisition that I like to give it as an example most of the time as a demo, I'm gonna use one for temperature measurement. Let's use one of them, which is the 9211. I'm gonna use it as to choose all the NI or most of the NI data acquisition they are available to start using them in simulation even in the code programming before they arrive to your field or to your laboratory. Let's use, for example, the 9211 and click OK. Now we have the data acquisition present here. We can name it whatever we want. Also, we can delete other simulated data acquisition in order not to confuse our program if we are beginner in this. Okay. And then we can now run Labview. And we have as well in Max something called a remote system. So this is very well used whenever you have a deployed data acquisition in the field, where we can program it remotely in order to save on time, cost of travel, and limitation of lockdown. After programming it remotely, we can install the code on it and have it running perfectly. Now I'm gonna close it and run Labview. So let me minimize this one. So once Labview is launched, I can now start building my virtual instrument code as Mr. Shadi was explaining earlier. I'm gonna create one HMI to build together the first HMI SCADA system Once we have Labview launched, we're gonna start Labview, and we're gonna have a new VI. We're gonna click on Control T, where we can have the two environment. Here is the block diagram as it was explained earlier, where we can draw our code, because Labview is a graphical programming language. And here, this is your SCADA system where you have to build your HMI. Let's start with a small simulation. We can simulate just for the sake of time, one random number. Let's start with one random number between 0 to 1. And then we can now multiply it by a certain knob. Let's create it here. It's kind of a dialer. Okay, multiple. Then immediately it's created here, where we can connect it as a data flow programming. And then we can run here a certain comparison algorithm. Let me see, comparison. If it is this result, if it is higher than a certain constant, then we're gonna create an alarm. Let's have the constant, for example, here 50. And then we can have the alarm here to say that is high. And we can also create or like configure it to be whenever it's high to be hot or red, and whenever it's off to be transparent, in order not to confuse the user. And as you can see, the result of this comparison, it's a Boolean value. And now we can put all the code in a while loop. Let's put it here and loop our code. And in order not to go to infinite number of iteration, let's click for it a certain loop condition, or we can go here and click create control. Okay, at the same time, we can have a small graph to illustrate the results. Okay, let's put the graph inside, and then we can put some signal merging. We can get it from Express, signal manipulator. We can get the list of the functions of all the signal analysis. Let's take the first signal, which is the multiplied by a certain value. And then we can compare it to the second one, which is the reference, which is 50 here. And now to this, both of them, let's put them here on the same graph, and we can start by clicking run. We can remove the auto scaling from the y-axis and put it here up to 100. And as you see now, this is the reference, which is 50. And because this is a value of random between 0 to 1 multiplied by 0, so the result is always 0 and the alarm is off. As soon as we multiply it by a certain value, the value is gonna increase, and we can now increase the knob up to 100, and we can increase it above that level as well. As you see that now we are barely reaching the 50, but as soon as we exceed it, the alarm will be clicking immediately. In order to make it more visual, let's add some timing. In this timing, we can introduce some delay. And in the timing, we have multiple functions. We have the wait millisecond and wait until next millisecond, where Labview can go low level to control itself or to control the machine, the CPU, and the core of each CPU. I'm gonna show you this one later. Let's create a control for it and made for the delay a certain value, so we can delay the loop speed. Now the loop speed is still at its own maximum speed. Let's add 100 millisecond. And as soon as it's added, you see now that you can start seeing the value. Let's add it to 200 millisecond. Again, the code will become slower and slower. And as soon as we increase the multiple value, and as soon as it comes here, you will see it blinking or getting alarm. Now, what is very easy to go live and have our first IoT system, we can do tools, web publishing tools from Labview. It's here when you can go to your block diagram, run web publishing tools, and host your VI to transfer your own computer into a server base. So you will be hosting your own web server from your own computer. So let's request to have access to it and start our web server. Yes. And we can start seeing it as soon as it is built. Once it's built, I'm gonna immediately click on a preview in browser. Let's as well save it and publish it. You have to use your Internet Explorer because some Google add-on protections or security might not allow you to publish it. Now you can have it. Anyone who is on our virtual public network, our VPN, he can click on the Internet Explorer, request access, change the values. Everything is online. I don't know if you are able to see it, and access your code. Okay. So I'm gonna stop it right now, go back to the code and click stop. Something that we can now do it as well, clean our code, Control U, and here as well, the code is clean. It was brought up in the earlier discussion that we can use several softwares for the programmers, because as Mr. Shadi mentioned it perfectly, that Labview is mainly for engineers, but still it accommodates the use of the programmers. We can call Labview to get from it several, let's see, express. We can get some inputs. We can ask for some data acquisition, and also we can get the use of the very useful programmer language like C language. Here we can import any code from C. This is an example from C language. Also, we can import some code that we have already built from MATLAB. This is one code from MathScript library. I have a code that I built in MATLAB 20 years ago, actually, and I will be adding it today. Let me add the code, doing some importation from one of the folder where I saved it already. And this is a simple code that is doing FFT, the fast Fourier transfer. Okay, so now Labview, let's see it. I don't know if you are able to see it or the screen is a little bit small size. As you can see that there are some error in line 1 and line 2 and 4 and 6. And this is very simple because the my signal input is not declared. So let's declare this variable, add input, my signal. Once the my signal is created, automatically Labview notified me that the MATLAB code is correct, and I can simply now connect it to the result of my code and do FFT to my generated signal and display and transfer my data acquisition from a time-based oscilloscope into a spectrum analyzer without having the need to buy neither an oscilloscope nor a spectrum analyzer, by simply having the data acquisition, the data analysis, the data which was measured very good to display its time domain display and display its spectrum analysis. And here I can simply say right click, add an output FFT result. As you see here from the expert in MATLAB that this is a complex number, which is part of it is imaginary and real. So we can put it in one table and create for it a display. Let's create an indicator for it. Okay, now let's reorganize a little bit our code and see the results. In addition to this, what we can do in Labview, let's make something more challenging. I can duplicate the code to have several inputs, multiple input, multiple output, copy, paste. I will have now two loops. Let's say the first loop and the second loop. And Labview, I can control the execution of each of the loops in a very parallel way. How? I can simply change this while loop into a time domain loop. And I can go to control it by the loop scan, by the loop speed, the loop priority, okay, like the interrupt request, how we used to make it on the DX4 and Pentium 1. Also, we can control it manually to see each loop on which core it's gonna be executing. So it might be on core 0, core 1, core 2, core 3, up to core 7, because this is iCore 7. And so on, okay? So if you have any question now, I am open to listen to it. Also, I hope that you have enjoyed this part related to Labview and to the Sapp's RDS offering in the region. And thank you so much for the time.
Thank you, Ralph. I think now if any student or, like the organizer, if you have any questions for us, we are ready to answer your questions.
Participants, any questions, you can unmute and you can ask. Sir, good evening. Actually, I am Dr. Devi Vigneshwari. I have one small clarification. Actually, is Labview allotted for Labview we can use for power quality disturbances also? Can we capture the signals of power quality issues?
Ralph?
Yes, indeed. In addition, Labview has a power toolkit. In this power toolkit, you can have all the basic power analysis measurements like active power, reactive power. You can have also some studies on the harmonics. And in one of the good applications for machine condition monitoring, also we have some very smart power protection toolkits where you can, based on the nature of the current and the transient studies, protect your motors in order not to get faulty.
So even transient separate toolbox is available inside Labview.
Yes, so you have a full toolbox of transient analysis. For the software limitation, there is no limitation. The only possible limitation would be in the hardware. Why? Because you have to rely on a certain hardware and very high speed analog to digital converter and very high resolution semiconductor equipment that can get for you those signals. Because in Labview, you can, for example, very easily order the hardware to make a simulation up to maybe 100 gigasample per second per the channel. However, if the hardware cannot respond, immediately the driver will fail and the analysis will be wrong.
Okay, fine. Thank you so much. It was very wonderful. And is there any open source tool by which we can access Labview, or it is only by paid versions actually? Can the students try in an open source?
There are the two possibilities. There are some of the codes which are available on the NI forum, which you can find a plenty of codes developed by students committee, by Labview student ambassador, and by fans of Labview. There are also LinkedIn page, Facebook page, where there is a very big community of people who are ready to help any question.
Okay, sure. Thanks so much.
Sir, thank you very much. It is a very detailed explanation to us. We are very lucky to know about that importance of the Labview. But 1 or 2 days we will conduct one FDP or workshop for the students. Really, we come to know how much importance in the industry for monitoring and come to know about the conditions and how to be control the units. All everything is very detailed. You are explaining. Really, we will plan for one Labview workshop for the students and faculties also. So its information is marvelous, very excellent information, sir. Really, thank you very much. So if further any requirement in this Labview, definitely we will be contact you. Please kindly guide us. So how we can be
Thank you
enrich
so
our
much for
students in this particular tool. Rafs.
Thank you for giving us the chance of explaining about Labview philosophy and ecosystem, and for your time, and Mr. Shadi for inviting me as well, and you for your time, guys.
This information
Excuse
is
me.
the right time, the right place. You given the information, sir. Really, it's really helpful. Students also having the lot of confusions to which thing they have to learn and explore themselves. So definitely, such a tools will be definitely will give some interest and motivations to them to further to study well this particular tools. Thank you.
Welcome.
Any other doubts from participants? Can unmute yourself.
Hello, sir.
Hello.
So actually, I have a doubt. Can we implement even the deep learning concepts and the neural network concepts in this, sir? Like when we are using the project?
Okay. Ralph, do you want to answer, or it is your specialty?
Yeah, but I am sorry, I didn't hear the question. There was some interruption in the voice. Would you please repeat the question?
Yes, sir. Actually, can we use the neural network technology to this Labview, sir? Like neural networks or deep learning concepts or even the Python concepts to this, sir?
Yes, thank you for this important question and for referring it to me again, Mr. Shadi. So, neural network, fuzzy logic, LQR,
Machine learning.
RCP toolkits, they are all supported by Labview. So machine learning, all the codes of artificial intelligence, they are all supported by Labview, and we are also welcoming a new expertise to build more intelligent machine learning, artificial intelligence expertise, and it's of a very high demand. As you see today, nobody can move without those predictive analysis and predictive next state positions or next state's value. Like even Facebook is doing artificial intelligence today. YouTube, all the smart intelligence is deployed not only in the applications related to software, but also to the hardware. For the machine also, we can predict its failure by applying some neural networks algorithm, by applying some fuzzy logic and the traditional PID loop and rapid control prototyping things.
Yes, sir. Got it. Thank you, sir.
Thank you.
Excuse me, sir.
Any
Yes.
For the projects simulations, can we can do these projects in this Labview, but how buy this from which website, or it is a free of cost, or we should pay for the software something?
Okay,
Again, I guess this part is for me.
I can answer this part, and then will he asking, you know, like as a student he wants to make some projects in LabView, from where he can get LabView, and what, you know, like the limitation of this LabView. I'll tell you from my experience, since I'm working in LabView in academic since more than 10 years, 2008. Now, in LabView, they have something called academic license. An academic license, from my experience, you can install it in your computer, or, you know, like in your department as well. And not in one computer. If you have the academic license, you have so many toolkits. So it's going to have like most of the toolkits which are available in LabView. It will be available in the academic license, where you can install it in different labs, not only in one lab or one computer. So basically what we do here in Jubail Industrial College, we have the academic license. We pay, you know, like every year, like subscription, some fees, and we can install it in our labs, in different labs, as well as in our, you know, like we have a lab dedicated for projects. So all of the computers which are in this project lab, they have LabView version, and usually every 1-2 years we update it to the latest version of LabView. Now, the academic license, as I mentioned, it has most of the toolkits. And from my experience, you know, like I'm not in the financial department, but I worked in 10, like 9 years ago. It has a special offer for the academic. It is not like for the industry. If you go to the industry, they have different category and different, you know, like paying method. But for the academic, it is much less than the industry. Okay. And there, if your university, they have the academic license where they can install it in all the department, then you have all the kits for you, all the toolkits, LabView toolkits, and then you can work with these toolkits, starting from LabView and the other toolkits. For example, power systems. Since my specialty is power, most of the project I did in power, it was, you know, like the power factor correction. I did the project in 2009, repeat the project in 2019. In 2019, the toolkit, the power system toolkit was there, and it was, you know, like we finished the project in 2 days, where in 2009 it took like 5 weeks in order to finish the projects. Why is that? Because the power system toolkit, it was, you know, like introduced by LabView, and we use these toolkits which is ready made in order to make the project. Okay, so just in short, there is academic license for the universities. If they bought it, then you can work with it. Ralph, if you have.
Yeah, thank you for this nice explanation, Mr. Shadi. Actually, the academic price of the LabView, it's very massively discounted. If you compare to the price of the industrial license, which might cost easily $150,000 to $200,000 per computer, the price for the university is discounted by 90%. And you can easily have it, and you have lots of benefit after you get it, not only at the student level, at the professor level, but also it includes the student install option, where the students will be eligible to have also the license on their computers at home. So it will perfectly help them for their e-distance learning from their home to the university, and their license, it will be like locked to the university license, and they will be doing their exercises and sharing them with their professors in a very secure and smooth way. In addition to this, if they want to get as a student the student version, they might even get it online. They might first of all download the student version online free of charge for sure. It might stay at their computer more than 42 days upon subscription. And after this, they can either buy a perpetual license, which you can get for it several years of services. The benefit of the services is that you can get on yearly basis the latest updates. Like as Mr. Shadi was saying earlier, the power quality analyzer was not there in 2008, but suddenly once it was released, he was able to get it. If someone got the Labview 2016 before the launching of the 5G network, and one got the Labview 2021 where the 5G toolkit is in there, he will not be able to benefit from it if someone got still using the 2016 because it's not included in the service. So that's why we always invite you to stay up to date. Guys, with the robotics, there was some question earlier about the feedback system and the neural network kind of add-on toolkits. Like in the past, we used to have only PID toolkit. Later on, they added the fuzzy logic. Later on, they added the LQR, then the RCP, the rapid control prototyping. Then they added the neural network. So it's always an invitation because there is no, every day there are updates. And what's happening at National Instruments, we are always making sure to include all the new release with twice a year with the latest software update. The one of the student standalone, you can get it maybe at $100. You can buy it online at an website or any website, but it's not the one that is related to the university.
Okay, thank you, sir. Thank you. So you told from website we can download that 42 days software. Is it that free trial for 42 days or we should pay for it?
No, there's gonna be a free trial version download. You can download it for Macintosh or for Windows, and it will start by giving you the possibility to get it for 7 days. Then you need to make registration, and it will give you an extension for 30 days, and then you need to have an NI profile or account. Then it will give you another extension, but in a total, it will not exceed more than 40 to 45 days for the free edition, okay, after the free download. Later on, you need to register it and pay for it.
Okay, thank you, sir.
Welcome.
Okay.
Okay. Any other questions? Oh, okay. Sumita ma'am, you can conclude.
Yeah, ma'am. Yeah. Good evening, distinguished speakers, HOD, participants, and colleagues. It's a great honor to propose vote of thanks to all who have helped us in making this webinar a grand success. On behalf of the Oxford College of Engineering, I, Sumita TL, Assistant Professor, EEE Department, take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this webinar. First of all, I would like to thank the distinguished speakers of the day, Mr. Shadi Mansi and Mr. Ralph Sapp, for detailing about the Labview applications in electrical engineering. Mr. Shadi Mansi gave an overview of Labview data acquisition and explained how to work on Labview with an example. Thank you, sir, for your valuable information. Mr. Ralph Sapp gave a very detailed presentation on the programming side of Labview, and his example of the spectrum analysis of a signal using FFT technique was very informative. Thank you, sir. I would like to express our profound gratitude to our Honorable President and Chairman for his motivation. I would like to thank our principal and directors for their enthusiastic support and guidance. I especially thank our HOD for his constant encouragement towards the conduction of this webinar. Special thanks to the organizing committee and teaching faculty of EEE Department. Our heartfelt thanks to all the participants. Your active participation made this webinar a grand success, and I am sure that this webinar will be of great help in your career and in execution of your projects. With these warm words, we move to the end of this webinar. Thank you one and all once again. So we have come to the concluding part of this today's webinar session. So we have posted the feedback link in the chat. Kindly all the participants fill it to receive the certificate. Thank you.
Thank you.
Thank you, sir, for both of you for spending your time. Thanks, sir.
Thank you so much, and you are welcome to visit our website. We have a page also for hiring for
Yes,
the
sir, sure.
candidate.
Yes, sir, sure.
Thank you.
Thank you, sir. Thank you, both of them. Thank you very much.
Bye-bye. Have a good day.
Bye-bye.
Excuse me, ma'am. Excuse me, madam.
ಹೇಳಪ್ಪ ಹರ್ಷಿತ್
ಸರ್ ಅದು ಫೀಡ್ಬ್ಯಾಕ್ ಲಿಂಕ್ ಎಲ್ಲಿದೆ ಸರ್ ಅದು?
ಅಲ್ಲ ನಿಮ್ದು ವಾಟ್ಸ್ಆಪ್ ಗ್ರೂಪ್ ಇರುತ್ತಲ್ಲ ವೆಬಿನಾರ್ಗೆ, ವೆಬಿನಾರ್ ಗ್ರೂಪ್ ಇದೆಯಲ್ಲ ವಾಟ್ಸ್ಆಪ್, ಅದ್ರಲ್ಲಿ ಬಂದಿರುತ್ತೆ.
ಅದ್ರಲ್ಲ ಓಕೆ ಸರ್. ನಾನು ಟೀಮ್ಸ್ ಅಲ್ಲಿ ಬಂದಿರುತ್ತೆ.
ಇಲ್ಲ ವೆಬಿನಾರ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಒಂದು ವೆಬಿನಾರ್ ಗ್ರೂಪ್ ಅಂತ ಇದೆಯಲ್ಲ ವಾಟ್ಸ್ಆಪ್ ಅಲ್ಲಿ, ಅದ್ರಲ್ಲಿ ಬಂದಿರುತ್ತೆಪ್ಪ.
ಓಕೆ ಸರ್. ಥ್ಯಾಂಕ್ ಯು.
ಓಕೆ. ದೇವಿ ಮ್ಯಾಮ್, ಥ್ಯಾಂಕ್ ಯು.